Hello everyone. So today we'll be solving a numerical on Gauss Divergence theorem. So the question goes like this. Given a vector field A equal to 30 e power minus r, ar cap minus 2z a z cap in cylindrical coordinate, prove the Gauss Divergence theorem for the space defined by r equal to 2, z is equals to 0 and z is equals to 5. First of all, let's write what is Gauss Divergence theorem. Okay, so it goes like this. Closed integral of normal component of the electric flux density is equals to volume integral of del dot D over the volume that is enclosed by this complete surface. Okay. So now let's start solving this. Let me write the cylindrical structure first. So the coordinates for the cylindrical structure as we know are r, phi, z. Okay. And here it is defined by r equal to 2. So from here to here, let's say it is r equal to 2 and this is z equal to 0 and z is equals to 5. Okay, what varies is only z. You have to note that. And see, cylindrical structure. This one has three surfaces. One is the top, curved surface and the bottom surface. So when you're considering the total flux enclosed, this will be given by flux enclosed by the top surface, flux enclosed by the bottom surface, and flux enclosed by the curved surface. So easy to write. Psi equal to psi top plus bottom plus curved surface. Okay, so what I have done right now, I have considered LHS. So let's consider the top surface. Okay, so first of all, the equation is d dot ds. D already we have. That's the given equation. What about ds? This is in which direction? This is in positive z direction. Okay. So now this becomes d dot dsz az cap. So when you do the dot product between d and this az cap, what remains is only minus 2z into ds. Okay, I have to write anyhow ds in the direction of z. And what is that? That is nothing but r d phi dr. Okay, I'll write that here. Okay, one thing what I have done is instead of considering it as a, I have written it as d. Okay, please do note that. So now for the top surface, I'm continuing. D dot ds becomes integration, that to double integration of minus 2z into r dr d phi. So I have to integrate with respect to r and then phi. Phi, they have not given any limits, so we are taking it as 0 to 2 pi. R also, I'll just take it as 0 to r, or you can even write it as 0 to 2 as well. No problem. So this is nothing but psi top, and you will get the answer as 125.66. Okay. So what exactly I have done here? See, this is psi top, and at the top surface, z value is nothing but pi. Remember, at the bottom surface. Now let me consider psi bottom. So here, d dot ds. Again, you will have the same thing, but changes will be in minus 2z r dr d phi. Here it will be minus, it was minus az cap. I'm not writing that because we have taken the dot product. So this minus I will write over here. Okay. But what about z value? Z equal to 0. So obviously psi bottom is also equal to 0. Okay. Next, what we have to find, one more left is psi curve. Psi curve is in which direction? See, this is a cylindrical structure. And where is this curved structure? See, this is the curved structure, right? And this is in the direction of R. So now instead of ds, what I'll take? I'll take dsr AR cap. Okay. So what happens when you take d dot ds? What remains is only the first term because you're doing the dot product. So that will be 30 e power minus r dsr. What is dsr? It is nothing but r d phi dz. Okay, I'll write that. Again, these are all surface integral. I have to write double integrals. So now I have 13 e power minus r and then r d phi dz. So now I have to integrate with respect to phi. Also z. Z is 0 to 5. And what is the value of r? Value of r they have already given, right? R is equals to 2. That itself I'll write because it is for the curved surface which is at a distance 2 from the central axis. So this d dot ds now will be with respect to phi. I'll just do it as 2 pi into 30 e power minus r into r. Okay, r value I have to give it as 2. I have not given it. And then with respect to z also I have to do. So 0 to 5. And this one turns out to be 255.1. What you have to do, just substitute r equal to 2. Okay. So now let me consider the whole flux, nothing but closed integral of d dot ds. What it will be? Psi top plus psi bottom plus psi curd. That is nothing but 255.1 plus 125.66. So this one will be, see, I left a sign here, I guess. Just a minute. Let me go back. See, there was a minus sign. I just left that. I'll write it here. Okay, so similar way, I'll write a minus here as well. So this equation changes to be 255.1 minus 125.66. So the answer is 129.4. Okay, so this is the overall flux. Now what we have to do, we will consider RHS. And RHS, what we had? Volume integral of del dot D. So in order to obtain this, first I'll have to find del dot D. And this is which system? Cylindrical coordinate system. So in cylindrical coordinate system, what's the equations for del dot D? 1 by r, dou by dou r of r into dr plus 1 by r, dou by dou phi of d phi plus dou by dou z of dz. Okay, so we have dr equal to 30 e power minus r. There is no d phi. Dz is equals to, we had it as how much? Let me just go back to the question. It was minus 2z. Do the differentiation and then get the value. So del dot d will be, I have to do r into 30 e to the power minus r and then divide by r. So this comes around minus 30 e power minus r plus 30 by r e power minus r and then minus 2. Okay, so here r into 30 e power minus r, you will have to use product rule for differentiation. And then we have dv for cylindrical coordinate system as r dr d phi dz. Do the volume integral again. Volume integral means what? You have to do integration 3 times. See, I forgot dv again. With respect to r, phi, and z, and I am writing del dot d, which is nothing but minus 30 e power minus r plus 30 by r e power minus r minus 2 r dr d phi dz. You can multiply this r inside and then you can do the integration. So we'll start with the dr first. So overall integration, it comes around del dot d dv is equals to 129.4. Okay. See, we have proved this initially also when we had considered closed integral of ds, and that becomes equal to del dot d dv. So yes, what we have proved? We have proved Gauss divergence theorem. Okay, that's how you have to solve. Thank you.